In week 2, we have learned about laser based powder bed fusion, electron beam powder bed fusion, various types of DDs, sheet lamination, and various types of process control. Now, let us take a closer look at what we went through. Based on the principles of powder bed fusion, we know now about laser based powder bed fusion, material jet fusion. We also have learnt about direct energy deposition. That means we now know about laser based DED, electron beam DED, and arc DED, and similar processes. The squares which are highlighted in blue, as mentioned earlier, are the technologies which are available with Wipro 3D. We also learnt about sheet lamination process and its applications. We have also learnt about various hybrid additive manufacturing processes. The powder bed fusion process essentially is based on selective melting of a bed of powder. The powder can be melted using either laser source or electron beam source. Various types of metals and alloys can be printed using this. For example, aluminum alloys, copper, stainless steel, titanium, various precious metals, and also polymers. Based on raw material and energy, the powder bed fusion process can be categorized into two types of processes. One are polymer based process, the other are metal processes. Based on energy, they can be categorized into laser process and electron beam based process. We also talked about various manufacturers of additive manufacturing machines and various types of machines they offer. We then looked at various models of these additive manufacturing machines, what type of build sizes can be created using additive manufacturing machines, which type of energy sources are used, which metals can be printed in each of these machines. We also looked at various types of controls that are available in these various models. We then compared two different machines, one for small size and other for larger size. The one of these machines, the larger size machine, offers also additional gas flow controls and powder flow controls. We looked at various parameters using which gas can be controlled in the print chamber. We also looked at how powder bed can be created, how powder can be spread. We also looked at the powder flow and recycling of the used powder in these two machines. We discussed about electron beam powder bed fusion. The principle is similar to the laser bed powder fusion, except that the energy source is electron beam in this case. We also discussed about various components of electron beam melting. We then looked at direct energy deposition, in which the powder is not available in form of a bed. However, the powder flows concentrically from where the beam is directed to the platform, and also the inert gas flow is available so that the powder which is being fused or deposited is protected. Using this process also, various alloys can be printed, for example titanium alloys, aluminum, Inconel, various types of steels, tungsten and niobium alloys. This process also, based on raw material and energy, can be categorized into powder based DED and wire based DED, where the feedstock is wire, not powder. Based on the energy source, it can be categorized into laser DED, electron beam DED, plasma DED. We also discussed about kinetic energy DED, where the powder is projected on the platform, built platform with very high velocity and no additional energy source is used. We discussed about sheet lamination, where the 3D printing is done by putting the layers of the metal sheets or polymer sheets on top of each other, and those sheets are helped with an energy source so that the bonding or joining at the selected places can be done. This method can also be used for various alloys, aluminum alloys, copper, stainless steel and titanium alloys. However, relatively lower melting materials are used for 3D printing using sheet metal lamination. We also discussed about various hybrid and novel technologies. For example, we talked about melt extrusion deposition, digital composite manufacturing DCM. We discussed about diffusion bonding of aluminum, where 3D parts can be created by putting various sheet metal aluminum on top of each other. We also discussed about microelectronics 3D printing and newer techniques which are based on laser powder bed fusion. We discussed about friction energy based methods, where 3D printing can be done layer by layer by using this rotating tool, which creates heat because of friction and really large parts can be created. We discussed about a newer technology from Seurat Technology Incorporated, where a single beam of laser can be split into multiple beams and simultaneously many pixels can be heated and much larger areas can be printed and really complex geometries can be created. We also discussed about Triestech technology, which is being used for 3D printing of pharmaceuticals. This technology is being used for creating smart tablets. These smart tablets have various regions which are designed such that the actual drug which is inside the core of this tablet can be delivered in the pre-decided time at the pre-decided location.
Comes to this design, development in design and process monitoring, we have seen what are the various domains which is available in additive manufacturing, and then we have eliminated post processing which is not into our context. So, we have eliminated and we have discussed about the other 8, and then we have seen about part identification, where we have taken into account about part count reduction, that is part consolidation you can consider, and we have considered about sustainability, and then we have seen supply chain improvement. These are some of the factors which will be used to identify the parts, and also we have seen about certain software tools which are helping us in identifying the parts. The next one is order management system, which we have seen, where we are taking into account of certain operations like automated code creation, okay, because we have seen that code creation is one of the critical aspect in additive manufacturing, because each and every product will have a different type of post processing requirements and design requirements. So, code creation is a very important step. So, automated code creation is a requirement in the order management system, and scalable order management system we have seen, and then reporting and analytics. After which we have seen about design and optimization, on which we have seen about basic CAD modeling itself. By considering all the design guidelines, we do the CAD modeling, then if required we will be implementing some lattice creation, and then topology optimization can be done and generative design can be done. We have seen about different type of tools which are used for making this design and optimization. After which we have seen about build preparation. Once the design is ready, we are taking it to the build preparation stage, where initially we are fixing and editing the model. That means if any triangles are missing or any surface is not proper, then we try to fix and edit the particular model. After which we take it for support generation, where we generate the support structures required for the model. And then we do the orientation and nesting, where in certain technologies nesting is possible, in certain technologies nesting is not possible, and even in certain technologies we do the orientation first and then we go for the support generation. After which we have seen about process simulation. Here we have considered three main aspects, that is defect identification, because even before getting the part printed we will make sure we will do a process simulation and then identify the defects which will be happening during the printing stage, so that we could able to make some changes in the design or otherwise in the process parameters. And then we have seen about distortion detection and also residual stress detection. After which we take it to the build processor, which will be generating the code which is required for sending it to the machine. But initially in the build processor we will be assigning the parameters, that is like laser parameters it can be, or what will be the printing speed, or it can be of many types with respect to the technologies also. And then we have seen about slicing, that means based upon the layer thickness which is provided in the parameter, the slices will be generated, and then toolpath will be generated, that means for each layer, that means for each slices we will be generating some toolpath, and that will be generated, and both the details, that means in the form of a G code or a particular machine required format, that file will be transferred to the machine. And later which the printing technology uses the details from the previous step to get the part printed. Then we have the process monitoring step here. The process monitoring is used for identifying the defects and anomalies in the real time. That means when the printing is happening, during that time if any defects are happening or if something is going wrong, you could able to find it in real time. It can be using any type of cameras or otherwise temperature control units, or it differs from technology to technology. And we have seen about monitoring the key process variables, like whether the build temperature is being maintained, or the bed temperature is being maintained, or what is the flow rate of the gas which is maintained, whether enough nitrogen or argon is being available inside the build chamber. So these kind of things we will try to keep on being monitoring. And finally we have seen about manufacturing execution system, where we have seen about planning, rule based scheduling, material management, tracking, quality checklist, manage the machine downtime. So this can be controlled using some software tools which will improvise the overall production environment. With this we are coming to the end of the summary. Thank you for watching this lecture.